We'll be talking about failures today. And I don't want to say that this topic is close to my heart, but it is. And I felt a lot, and I want to share my story with you, and maybe bring you some kind of inspiration, and maybe also increase a change need in your organizations and your attitude to software development. So let's start from asking one simple question, and it's not a simple question. Did any of you kill someone by the code or application written? And kittens killed by something when something doesn't count? No? I'm not from police? No? It's not on purpose. Let's move further. Okay, looks like we're fine, but we're not. We can end up presentation, thank you very much. But it's not that easy. I've attended one talk lately made by my colleague Marcin in Poland, and he was talking about safety critical systems, and especially software development around safety critical systems. And he changed my mind a little bit on what we are doing as software developers, because I presume that most of us are software developers, most of us are doing website development, most of us are also working with Umbraco on a daily basis. When software can kill, literally, we are talking about things like military, space, medical and industry, or transportation. And the guy which I brought to you seconds ago was responsible for the main system for the train operators in Poland. And he was working on it for 2 years and shared his journey about creating this software. And it was totally different journey than ours when we are building a website or software like the web applications. And why? I will just move this cursor from here. And why? Because it's well documented. They have norms, they have certifications, and they have requirements for their software, and not only for their software, but also for the process. So for example, this is a aviation industry process and certification. If you want to write a software which is responsible for something in the plane, for example, you have a level A certification, for example, and failure in this system can cause multiple loss of lives, and usually with a loss of the aircraft, for example. So if we are building a simple application which requires only a level E, for example, it doesn't affect safety, so maybe it's just a newsreader for the plane operator or something like that. Medical industry has its own norm, its own certification. They have only 3 levels of certification. For example, level C can cause a death or serious injury is possible. So a failure in software like that can cause a really damage. It's same with the transportation. You can also see the probability level here of each bug or each cause, for example, and risk of failure, for example, on level A here in the transportation is on the risk level of 1 in every 10,000 hours, for example. There is a security integrity level, SIL, in the shortcut, which tries to be an intermediate language for all of those norms. And it's not even listed here, but the highest level of security integrity level here is SIL 4. And we will be talking about this level on this slide, for example, because it's not only about probability and maybe just some kind of requirements for software. It's down to the code implementation, it's down to the software implementation, and it's down to people. And for example, here as a software developers, we can see the documentation, and yeah, I want to focus on a couple specific things. For example, in SIL 0, which is the lowest level of security, and SIL 4, the highest level of security, design and coding standards are mandatory on SIL 3 and 4 and highly recommended on every level of software, for example. Same with strongly typed programming language. Let's cry right now that we are not able to build safety critical system in Python or JavaScript, for example. Whoever will try it. But modular approach is highly recommended or mandatory in every single level of that. Going further, we have verification and testing requirements. And traceability is mandatory into the highest levels of creation of software like that. Test coverage, highly recommended almost on every level. Same with functional black box testing. And the last 2 slides, as the software developers, most of you probably are software developers. For example, singleton hools, no more singletons in some of the implementations. We are not able to use any global variables in SIL 3 and SIL 4 software certificated with those certifications. So it's very well specified, it's very well documented, and the requirements are pretty clear, and we know them ahead of the time when we are sitting and coding something in our systems. The last screenshot is only from the language perspective, because I wanted to know if C# is capable of doing things like that, and it is. But the most popular language in safety critical system is ADA, or Modulo 2, and I didn't know about them at all. So they are responsible for taking care of the systems on high risk, really. But C# is also good. No JavaScript, no Python. Sorry. And when it comes to implementation, I, as a software developer, and looking on my past, I would probably stay in this implementation development process and this underneath the ground for a long time before going out on the top and testing and replacement and delivery from time to time. But they have a really well-documented process. It's called a V model. So they have a requirement on every step like that. They have documents which are confirming that the requirements were met. Then they are implementing something, testing it, and on every stage of testing it can come back and requires the same amount of documents, the same amount of process, the same amount of energy. So it's not easy to break something here if you are in the second or third cycle of the process. Each step, as you can see here, has a document approval, so it's coming through the multiple teams, multiple people to confirm that it's ready to being implemented at all. And just to maybe show it in more in depth when it comes to documents, this is a list of documents required to create on every step in the transportation of software development process. And it brought a really interesting thoughts for me, because I'm too lazy to write a single documentation for my function or method, and they need to write this ton of documents to implement a simple feature for safety critical system. It's different perspective, right? So the final thoughts from this introduction is that good engineering is not only about the code. Code is just a small puzzle in the whole process of creation of it. And second thought, slower can be faster. We are taught that testing can slow down our process of delivery. Right now, time to delivery is one of the biggest measures and the most desired ones in the design industry and the development process. But it's not like that. If we will save some time writing really good documentation or requirements documents, we can save a lot more at the further stages of the project. It's a picture with a not finished bridge, which I called an MVP. You will be able to see it when I will share my slides after the talk. The children are working through this bridge, but this is not completed product. And we, as web developers, usually are competed with the MVP products. And I was involved in some of those products, and I can say that the MVPs are sometimes the final products. And we write a shitty code in our MVPs because we will fix it later, right? And from you here, who is having or estimating a time for refactoring and performance optimization in each sprint of your software development process? Hands up. 5 people. Awesome. 5% is a really great metric from it. But yeah, we are not changing this code, and we are writing shitty code because it's MVP, right? And then MVP is going live or to production, and we written a shitty piece of software, MVP. This is the bridge in MVP version. It works, right? People can cross the river. But yeah, we are working with those MVPs. We are working with software, websites, mobile applications, and we are always stressed. Most of us are stressed, and we are dealing with it. And when I came to the presentation about the software critical system, I said, I won't kill anyone, right? My bugs won't kill anyone. And this is my metric which I use right now. If no one dies, I'm safe. But I'm stressed. I'm 30 years old, but I think that I look better than John.
Not really.
No? I tried. And because of it, we fail a lot. We are stressed, under pressure. And when we fail, when my presentation failed, I can run away, right? But I stayed. So it depends how we are dealing with those failures. But as my idol said once, I can accept failure. Everyone fails at something. And if no one is failing, that's why I didn't want to have people like that on this presentation. If no one is failing, they are probably not trying anything new. Because if you are in your safe zone, you are not doing anything new for you. So you need to fail. And he can accept failures, but he cannot accept trying. And I don't know if you know, but Michael Jordan lost more than 300 games lost more than 9,000 shots during his career, and 26 times he was responsible for taking a shot which was a game-winning potential shot and missed. And still, he was, and probably is, one of the most recognized NBA players in all time. And when it comes to our processes, humans are the most important person in this process and the most probably failure ones. In aviation industry, 75% of failures is because of the pilot's mistakes, related with weather conditions, decisions, and everything else like that. Mechanical issues, 16%, and all the rest is 9%. I tried to convert it into software development and website development, and 75% of that is because of human mistakes. Easy. 16% hardware or automation, because we try to automate things, we break automation, and we break everything because of that. And 9% from that is unavoidable, and it should be totally acceptable. And I don't know if you know about this machine. Anyone recognize it? It's a Terac 25 machine responsible for radiation therapy in 1895, something like that, or 1985. Yeah, 1985. And it was a third version of this machine. It was someone made the stupid decision that in this version, let's control everything by software, not hardware. Our developers won't make a mistake. We can control everything by hardware. In those ages, when they were working, 11 issues were reported, 11 machines were working, and 6 people died because of the software mistake. And the issue was related with the safety mechanism, which was dealing with race conditions, because there were different states of the machine, and someone didn't check if machine is in different state and just forgot about making a bridge between radiation and the human. 6 people died because of this simple mistake. And mistake was really, really simple. I will share this slide. It was not, the race condition wasn't detected. The state wasn't checked. And that was a mistake made by a single person who was reading the whole code for this piece of software. It wasn't tested because someone was not having money to deliver a real machine to test it. And yeah, 6 people died, and the court was chasing people responsible for this mistake. Second one, beautiful rocket, beautiful spaceship, Ariane 5. 5 means that it's a version after 4. We are afraid of 5, right? And we should be. This 5 was also a bad one, because 37 seconds after the start, it looks like that. Yet another mistake, programming mistake, responsible for failure of this rocket ship. And fortunately, no one was inside because it was a race to just check something on the space. But 37 seconds, a lot of $1 million, $370 million was lost, and 10 years of work because of this mistake. And it's an ADA language. I'm not familiar with it, but we can see here a variable which, just as a joke, and it's not a joke, was copied from a code from version 4. And it was redundant here, totally redundant. And it caused mistake because the conversion from the 16-bit integer was not checked if it's safe at the very beginning. And they tested exactly the same scenario on the second spaceship after the failure, because they were investigating what happened. And they found that, yeah, this is this mistake. Why this variable is here? I don't know, we've copied the code from Ariane 4. It worked there, but yeah, it's failed here. And there were more situations like that. Tony Hare, British scientist who invented a quicksort algorithm, for example. 5 years after creating quicksort algorithm, created null exceptions, which we all love and hate at the same time. And he said at QCon London conference that, yeah, it was because it was so easy to implement it. We needed some kind of safe types to check. Sorry for that. Sorry, Tony, not sorry. We right now are dealing with something like that in latest C# versions. We need to check if null is null. And if not null, we need to be sure that it's not null. Or not. Or we be smarter than compilers, or try to be smarter than compilers. So we are making mistakes. Everyone makes mistakes. But come down to Earth. No more space references. And Umbraco Poland Festival. We are here on UK Festival. We had a Polish festival more than 1 month ago. And we've created a website. It's our side project, right? It's a festival. It's an event for people like you. And we were very, very happy of releasing this website. As you can see here, I'm speaking with GIFs all the time. But a couple minutes later, someone said, Tom Madden shared an update that foo is not working. I said, foo, we don't have page like foo. why it's not working, why it should work, why someone would need to check for the page like that. And Tom said that, yeah, it's his normal practice, that he is looking for a lack of 500s or lack of 404 pages. And yeah, we didn't have one. And I said, yeah, it's not ideal. Yeah, it was done in a rush. Yes, it was me. Going to fix it. Thanks, Tom. That was my response. Good. And 1 hour later, after lunch break, we had a beautiful 404 implemented. Works, fixed. Thanks for feedback, Tom. If you're here, I will high five you. I felt here as well. I felt a couple times during this presentation, as you saw. You can see here, I didn't change the recording, and it's exposed that I'm using some kind of tool. It's another failure. Public speakers fail a lot. And you've probably seen issues which we faced in the beginning of my talk, but I don't know if you've seen this issue. And if sound can be turned on right now, or it's another failure during my presentation. A Samsung CEO was asked to come on stage and describe the idea of his invention, why he's so inventory, why he's so good in what he is doing. And the prompter went down. And he was not able to continue, and he just ran out of the stage.
Ladies and gentlemen, director and producer Michael Bay. Good afternoon.
Thanks, Joe.
Good afternoon, Michael.
How is everyone today? My job as a director is I get to dream for a living.
Michael, you know, you're known for such unbelievable action. What inspires you? How do you come up with these unbelievable ideas?
I create visual worlds that are so beyond everyone's normal life experiences. And Hollywood is a place that creates a viewer escape. And what I try to do is, as a director, I try to... the type is all off, sorry, but I'll just wing this.
Tell us what you think.
Yeah, we'll wing it right now. I try to take people on an emotional ride, and
The curve? How do you think it's going to impact how viewers experience your movies?
Excuse me, I'm sorry. I'm sorry.
Okay. Ladies and gentlemen, let's thank Michael Bay for joining us.
And if you will wait for another 20 or 30 seconds, you will see it. And I didn't run away from my stage today, right? And my prompter is also not working. I'm dealing with it. I'm better than CEO of Samsung, in this case at least. And because we are dealing badly with problems, we do stupid things. And things is a politically correct title for this slide. And we do stupid things. We make mistakes. And when we are doing it, I'm always referring to the book by Simon Sinek, Start with Why. We need to know why we are making those mistakes to fix them, because it's not enough to just fix it. So we are thinking why we are making mistakes as a software developers. We are under pressure. Maybe we are afraid of being judged. Maybe we are afraid of not delivering something. We are not sharing information about our, I don't know, attitude or our mental health, at least, for example. And we are feeling that we need to do something and we don't need to ask for help. It's one of the probably main causes of this failures in software development process. Then the second one, we are spread too much. I don't know if you saw the Malcolm in the Middle series, and here the main character is responsible for fixing the bulb, replacing the bulb. And he is finding that, oh, this is not working, I need to fix it. Then, okay, my car is not working, I will fix it. And at the end of the day, the wife is coming back and saying, hey, you were responsible for fixing the light bulb. What I'm doing, right? And then in our process, in our software development process, we are starting from something, ending up in another project, another library, fixing Umbraco back maybe in the open source project while we were supposed to deliver feature or functionality in our project, which was the most important part of the whole process, right? It's very common. We are spread across multiple projects, multiple responsibilities, and we fail in some of them because we are not able to do multiple things at the same time and finish all of them correctly. That's proved. The third cause is that we are not controlled. We are, for example, chilled as Snoop here, and we are building a website. We don't care if it will work or not. We are not responsible for it. No one will die, right? And that's why we are building bad applications. Yet another cause, blindness. And we've seen it a lot when we are working with Umbraco projects also, because when Umbraco is delivering features and doing something inside of the product, they are not always familiar how people are using it. At least it was like that until Umbraco Cloud, because right now they can see what are the issues with the software. But yeah, we are blind and we are not seeing what's going on. Sometimes in our companies, sometimes our teams, sometimes in our time management or our attitude to the software development. And if we won't see it, or we won't be listening to people who can help us and who are telling us, you are bad at it, you need to change this and that, and we won't be listening because we are 100% sure that we are correct, it won't work. And the last one is single point of failure. People are usually a single point of failure. If someone is going for a month vacations, how you are dealing with it in your companies? Usually it's a madness. Hand over, what are you working on? Please share it, commit, push, let us know about it. And then we are finding that, yeah, let's wait for him or her to come back. We'll fix it together. I won't be dealing with it. It was built by someone else. So yeah, we need to avoid single point of failures, and we need to be prepared for them, because if we won't be prepared, they will happen and they will break our process. And it all comes down to the communication. If we are bad in communicating things, we are not saying that we are in danger or we are having problems, then we are having them all by ourselves. And we are not able to fix them by ourselves, usually. So we need to communicate better across teams, better across companies, better across, I don't know, whole life, work-life balance as well, because we need to have a clear way of communicating bad and good things. And it comes to the 4 types of failures, 4 types of bad mistakes and software mistakes. Some of them are related with storage, some of them are related with hardware, software, which is most interesting for me personally, and other failures. It's like dominoes. One failure can cause another, and then we are really, really fucked. And do you know this software, this piece of software, TeamCity? Are you using it? We are also using it. And one of our employees who wanted to be anonymous today, probably he would like to be anonymous, decided to clear up space on our dev server. And dev server was full of bad things. We were doing some kind of experiments there. We are doing a lot of other crap there. And clean up space and create a new instance of TeamCity on another server to have a clear space and new space to deal with. He moved database, he moved everything, installed a new version of TeamCity, and deleted all the files from old server. And then we were starting creating new projects on our new instance of TeamCity, and saw that we don't have a project configurations. We don't have our baselines. And we were doing all of the new project configurations based on our baselines. And it comes to the end that the TeamCity is keeping those configurations in solid files, single files, not database at all. It's config files located on the disk, XML file. And they were gone. They were gone. We've lost, I don't know how much time, a lot of time, to restore it. And it was a really nice lesson for all of us to have backups, backups of backups, and not only have backups, because it's not enough. We need to be able to restore from those backups. And I heard an interesting idea lately about backups, and it was about staging environments. The idea was about creating all of the staging environments straight from the backup from live side. And it should be done automatically. It should be done without our time needed and efforts. And I think that it's an interesting idea, and I know that Umbraco is doing it with Umbraco Cloud, because you can pull content from live site and work on it. But it should work automatically with all of our systems. I still want to plug it in our process somewhere in time. So not only backups, because we can have list of files with endings of zip or something like that, if we're not able to restore it for what we are keeping it at all. And there is something like that called paradox. I don't have notes, and I'm not good at science. But it's some kind of paradox when a service failure causing a customer being more happy or less happier at the end of the day. So normal customer who is just using service or our system or our website without any failures is happy, right? If we've built something good. But if we have a failure of system here, and we are making a recovery, and we are doing it good, and we are ensuring that client is happy after the recovery, everything works, our backups, everything, we didn't lost anything, they are even happier. And there are some customers here who experienced failures and wasn't able to restore at all. And they are not our customers because probably that's why they are not listed on this chart. And we've heard about all of the hardware failures, but I don't want to talk more about hardware failures, but we can cause hardware failures as well. We have power tools like Azure in our hands, right? And we can click and cause the failures. We've built an automation lately, which was creating a databases for us automatically for every single environment. And we forgot about one single setting. We were forced to change manually model and pricing tier to Elastic Pool because every single database was created in the standard model, which cost £11 per month for a database. Imagine 200 or 300 databases automatically created, and our boss's face at the end of the month when the Azure invoice comes. Yeah, you can imagine it. And we can make it even bad, more bad when we choose a, I don't know, how it's called? Business critical level for the Azure, which costs £800 per month for a single database. So we need to know what hardware are we using. We had some clients who were using big servers for simple static websites. Why? They were paying hundreds of pounds for using servers like that to just handle static HTML file. They also need to know that this is not required. We need to tell them, communicate better that it's not needed. We can use this money to create something else, to build feature, to fix something, or I don't know, create something new. And code. Code is something what we all love, and we can create a lot of failures, but I wanted to focus on one of them. Exceptions. And exceptions are something which is really bothering me, because I know a lot of developers who are dealing with exceptions like that. Try something, if it fails, try to find a solution on Stack Overflow. If it fails, it's not possible to be built. And it's not, and we have different types of exceptions, we have different types of software, and this is called failing safe. So we are trying to hide every single exception in our solution, and we, at the end of the day, we don't know what failed, because meanwhile, we are not logging anything. We don't know about system at all. And if we take a look on, for example, web client implementation and try-catch block in this class, in C#, we can see that we can catch a lot of exceptions, web exceptions. We can check if the page was not found, if it was an internal server error, and deal with it. We can do something else for different types of situation, different type of failure from perspective of our code. And try-catch block is not only try-catch. We have a finally phrase at the end of the block. And who is using finally cases? Good. Still not so many people. And we can just do some kind of safe fallback to the situation before exception happened and do something with it. This is one of the approaches. The second one is more dangerous, but we can also create our custom exceptions. I'm really happy when I'm throwing exceptions from my system because I know what happened. I'm throwing exception, I can create exception, I can do something with this exception later. I can create an exception handler and do something with those exceptions on the separated class or separated system at all. But no one is doing it. Maybe not no one, but not so many people who are building software are doing it. And we can have a full control, but then we need to love to read logs. Who from here loves to read logs of the applications? Yeah, there are some people, yeah. And you know, when it comes to logs, we need to log and warn about things which we care about, right? I observed lately that I'm receiving a ton of emails about some failures in our systems, which are just told to me that, ignore that. It shouldn't be taken care of. It's not important. If it's not important, why I'm receiving email about it? Why? Why I should have information about all of it in my logs when I'm looking for some kind of error or exception or custom information thrown from my software. So we need to be aware of it. We need to log carefully, and we need to love reading logs and finding causes of our mistakes. And at the end, of course, it's about testing. And it doesn't matter if it's a manual testing, automated testing, I don't know, testing by students or some external companies, doesn't matter. Any testing is better than no testing. And we need to know what happened and how mistakes are made during the process to be prepared for them in the further stage of the implementation. But in my opinion, it's the last step. So if we're not prepared for tests, any tests, of course we are hearing about TDD, etc. It's a good approach, but if we are implementing it from the very beginning, it needs to be in place. We cannot apply safety to pre-existing system. We cannot fix it when it's failed from the very beginning. So one cause can cause another cause, and then we are ending up being killed by our own piece of software. And the final stage, not final yet, but one of the last stages of it is to learn from our mistakes. So we cannot just go away from the responsibility. We cannot transfer this responsibility on someone else. We cannot tell that Antone did it. We need to be, but he did it, man. We need to be responsible for our mistakes. And I like to be like Jim Carrey in this movie. Did you see Liar, Liar? He was forced to tell the truth for the whole day. Yeah, it was me. I fucked up. I made this mistake. How we can fix it? It's our team responsibility. We have the same goal. We need to deliver this software for our client, for ourselves. And if we failed, yeah, we failed. Let's fix it together. Not blaming people around that someone breaks something because he, I don't know, was or she wasn't capable or didn't have any knowledge about it. And about blame culture, it's also one of the causes in the companies. People are blaming other people and just going away from their responsibilities when they need to take care of it simultaneously and together. And I heard about companies who are awarding employees for number of bugs fixed. I said, what with people who are not creating bugs, who are not dealing with bugs? Should they be awarded or not? And lately we've seen a discussion on Twitter, Lars Erik shared it, about perfect developers. Who are perfect? Those who are doing things slowly but on a high quality, or those who are delivering fast and with a lot of bugs as well. And it depends, as always. And I think that's really just being responsible for what we are creating is one of the most important things in our implementation. And when it comes to communication, we need to communicate good, and we need to be aware of what we are doing together as a teams. I've mentioned that we need to handle it as a team. So when developer tells to the manager we have a problem, this problem needs to be understood by the manager. And when manager responds, it's not a problem, it's an opportunity, this opportunity is not good, right? So start with why. Once again, start with why we are having those issues, how we can fix it. And there are some simple tools in our hands, in our companies, such as retrospectives. I'm not a huge fan of Agile. I think that Agile broke a lot in terms of software development, because right now we can create shit and think that we are Agile, we'll fix it, right? But retrospectives are pretty good, but in my opinion they should be really important. So it cannot be a 15-minute meeting at the end of the week and someone said, yeah, I was disrupted all the week, I didn't have time to do that, we were communicating badly, and yeah, cool. Next Friday, the same things. We were overoccupied, we were not communicating good. We need to take actions from it. And ideally, if retrospectives are shared across company, we are doing it in our company right now, we are sharing notes from each retrospective, so the other teams can learn from other teams' mistakes. Which is very good, and I'm also again a huge fan of company-wise retrospectives. So if we are experiencing what other teams' problems what problems are faced by other teams, we can take the lessons from their mistakes and do something better together. And knowledge transfer, because of those retrospectives, for example, if we're sharing materials from our mistakes, we can transfer it. It's all about irreplaceability. Someone said that the people who are not replaceable, they are also not promotable. So if you are feeling that you are not replaceable in your team, you or your company are doing something bad, because you need to be replaceable. It needs to be possible to cut you from this project and place you in other project without any interruption or breaks during it. And we've implemented some of the simple methods to deal with it. Checklists. When I'm doing something what is important from my perspective in my project, I'm doing some notes. Yeah, I done that, I went here and there, and I'm just creating this checklist on our Trello board, and someone who is responsible later for doing the same thing can just check it out step by step after me if I succeed at the end of my checklist. And those are pretty simple, and those can be also delegated to someone else, right? If, for example, we have a lot of things which are possible to be done like within the checklist like that, and we had this situation in our past. One of our project manager was always asking to rebuild some application on our client staging environment. It was done in TeamCity, our well-known TeamCity. So we gave her a login, just log in there, you click Run button next to the project which you want to rebuild, done. Why create interruptions for communication, especially if we have remote workers like myself included, for example? It's really important to not interrupt our work, but just find a way to make it more efficient. And checklists are one of those tools. Lately, we also decided to record videos from our sessions or fixes. So, for example, if I'm dealing with Azure database, I'm changing pricing tier to Elastic Pool, I can record myself on a video. I can tell developer or someone else who will be doing it, man, don't click here, you will break it, or do something else with this piece of software. And the single problem of it is like that, if Azure changed the interface, and it's not there yet, not there already, but it's not so often, and it's still useful to deal with it like that. You can create a private YouTube list, private playlists related with clients, projects, or departments, Azure, AWS, and then point people to the videos from your intranet or from your Trello boards or somewhere else to just learn and do things exactly like they are exposed on this video. And if it's not enough to learn from your teammates and your companies, you can went to the events like Fuck Up Nights. I don't know if you heard about it. Those are meetups where people are jumping on stage and sharing their fuck-ups. Yeah, pretty good. I went to one in Warsaw, and I've heard a lot of interesting stories from people. And I then realized once again, I didn't kill anyone by my mistakes, and people are making a lot bigger mistakes than me. So it's really inspirational, really motivational, and you can find the closest meetup doing the Fuck Up Nights in your area and try to learn from their mistakes. Netflix shared a really interesting piece of software called Chaos Monkey. Anyone heard about it? Yeah, there are some of you. They are running a process in their production environment which is terminating one of the servers randomly, just to expose them to the issue and to let them know if they are capable and it's possible to recover from this failure. And if it's not, they are doing something bad. They need to fix it. And I tried to find out the way of killing one of our servers to find out if it's possible to recover, but I stopped on reading documentation of this project yet, but I can do it in the nearest future. But still, if we are able to recover, if we are able to not expose issues by load balancing, by traffic managers, so anything else which can help us to not expose our issues further, it's all good, we are all safe. Netflix is doing this way. There are some companies who are also introducing red teams in their own organizations. The red teams are some people who are responsible for finding the issues in our code. And they are safe to blame other people. They can point mistakes to other people, and they can just tell, yeah, Martin or Anthony, you fucked up, please fix it. This is a mistake, company-wise, red card on Slack channel, general. And it's really interesting thing. The red teams can be from internal of the company, and they can be also external. And I think that it's really useful if someone else will try to break our websites. Like Tom, for example, tried to find out that we don't have 404 page. I didn't check it, right? So if we don't have someone like that, we can always help. Ping me. And at the end, when we know why we made a mistake, what type of mistakes can be made, how to deal with them, and how fix them or try to fix them, we can then prepare for the next mistakes, because they will be there. We will make mistakes. We cannot avoid failures. We are building software. It will always fail, sooner or later. We are creating bugs all the time, and we are responsible for them. So we can prepare, and we can calculate risk. We can choose the strategy of creating our software. If we want to fail safe by try-catch block on our whole application, or if we want to throw exception and break the solution, because if it breaks, it shouldn't be run, and maybe then other instance should pick up the traffic from the website. And if we are prepared, we are less scared at the end of the day, because we will be at least knowing what can happen, because we analyze it. And software analysis, software failure analysis is really important. But even beside that, yet another team member who wants to stay anonymous. During our hackathon in Krakow, before a Polish festival, when we were building a chatbot live chatbot which can be opened on the website, and the messages from the chatbot are coming to our Slack channel, and they have some kind of automatic replies, etc., etc. We build it. We will probably release it soon. Decided to plug the test chatbot to one of the channel clients on our Slack, and then our client wrote a message. Hi guys, we are experiencing issues on the contents of site, and our Slack chatbot responded, hey, thanks for your message, we're all at the pub right now. So you know, even if you know about everything, you are not able to handle everything, you are not able to be prepared for everything. And referring to my previous slides, it's not bad, we were communicating it through, right? We were at the pub drinking beers and writing chatbot. So it's still openness, communication, clearness, and straightforward approach to our client. And the most important lesson at probably the end of my presentation, I've learned it at 30 years. I watched this movie, an animation movie, in the past, but I've relearned it lately. And it's Hakuna Matata. I don't know if you heard about it. It's a issues-free philosophy. You are not caring about issues. You are familiar with them. And Simba and Pumbaa were singing it a lot. I was watching it with my daughter lately. I said, Hakuna Matata. Yeah, really, that's pretty cool. If something fails, I don't care. It fails. Software, it's failing. I need to be responsible. I need to fix it, but not now because I'm watching Lion King with my daughter. And yeah, we need to be. If someone wants to a version for adults, I highly recommend this book. It's really amazing. It's changed a lot in my mindset of handling my personal issues, not only with software development, but also with my work-life balance, work balance, and all the rest which I was and still I'm facing. So Lion King, or Subtle Art of Not Giving a Fuck. And then we can repeat. So we've learned, we know what we've made bad, and then we can repeat and make lessons from our mistakes. And oh damn, it was on purpose. My name is Marcin Zajkowski. I'm from Cogworks. I'm software developer and Umbraco MVP here. I work with those amazing people there. Besides that, I'm running a programming school in children, YouTube channel, blog, and you can find me on social medias. It will be a pleasure for me if you will share if you enjoyed my talk, and let me know about you on these channels. And lately, I was stupid enough to promise that I will write a book for developers who wants to be more active in social media. So you can find a reference for this book on social media for busy developers or smfbp.com. And thank you very much for your attention.